Yes. All right, hello everyone. My name is Chris Adams. I'm speaking about planet-friendly web development with Django. Now, if you have been coding in Django for some time, you may know the name Chris Adams already. I am the less well-known, less successful, less prolific instance of Chris Adams in the Django community. And I was going to be talking yesterday before lunch, but talking to 350 hungry people is less scary. Sorry, 350 tired people is less scary than talking to 350 extremely hungry people. So I'm here this morning instead. Good morning. Okay. So my background, I started working with Django in 2008, but over the last 10 years I've worked as a designer, a system administrator, a product manager, a UX consultant, a user researcher, and yes, sometimes even a developer on various environmentally minded projects and startups. So this list here, Amy, Avoid Mass Extinction Engine. I worked in a company and they managed to burn through $10 million trying to make carbon calculation easy. Loco 2 was more successful, and actually that's how I got here from using Berlin. So Loco 2 is trains and also low CO2. So, and then T-Light is this thing that it's just a thing I made, all right? We heard about Tom Dyson creating this thing called Can I Turn It On? We built like a kind of kettle based on that, and we showed it in a really, really posh museum. And that's why, I'm not sure if you can see this, but I'm also known as Chris Adams, the environmentally aware teapot. So there's... I think I should put that on LinkedIn, actually. So my aim today is to provide some context for how what we do fits into the wider picture of the environmental side of this, and also kind of share a mental model for thinking about this when you're building apps. And I'm going to try and make this a bit more concrete, so you can understand about the decisions you make as Django developers, how they affect like the environmental impact of the things we build. But first of all, I'm going to be mentioning carbon dioxide a few times today. So I'm going to start with a very, very quick reminder on the greenhouse effect. So this is pretty much how it works. Okay, we have the sun here. The sun sends energy to Earth. That's useful, all right? Some of it gets bounced away. That makes the Earth visible. Now, what's special about the Earth is that we have an atmosphere full of gases, primarily CO2, which help bounce some of this energy back into Earth. This is useful. This warms up the planet, and this is why we call it the greenhouse gases, because this entire phenomenon is known as the greenhouse effect. So this is very, very useful. It makes life possible. So thanks, greenhouse effect. But over the last 100 years ago, largely as a result of human activity, we've ended up with greater levels of greenhouse gases in the atmosphere, particularly CO2. Now, more CO2 results in a more powerful greenhouse effect, which results in more energy in the system and a warmer world. Now, okay, warm worlds sound nice, but the problem is their reality is less nice. So you end up with like more extreme weather events, you end up with drought, you end up with destruction to vital ecosystems that we rely on, and in general, the kind of problems that scientists describe as existential threats to our civilization that can only really be solved by collective action. So since the mid-90s, we, and when I mean we, I mean the countries that have made up the United Nations, not like the team I'm in, all right? We've been meeting every year for a series of huge, long meetings to agree on what to do about this, and to do this aforementioned existential threat to our civilization. And after 21 goes at getting it right, in 2015 in Paris, more or less everyone agreed that we definitely want to limit climate change, and we definitely want to aim for less than 2 degrees of global warming. Now, this effectively created a limit on the amount of greenhouse gases we can emit, something like a carbon budget. So it kind of needs to look a bit like that. If we get to blue, we're safe. So those are the kind of changes we need to be making. And amazingly, if you've ever been in a long meeting with more than 3 people, like things are actually starting to happen, all right? So this graph here shows you CO2 emissions over the last, 20 years. That says 1990, but I think the resolution is too low for you to see. But this graph is basically showing you, this graph from the International Energy Agency, it's basically showing that global emissions are starting to level off, all right? And yet the economy is still growing. So last year, America and China, the 2 largest emitters on Earth, they've actually reduced their emissions, and their economy has still grown. So we're actually starting to decouple economic growth and prosperity from the emission of CO2, which is a good thing. Although before we start feeling too proud of ourselves, we kind of do need a sense of perspective, right? Because we've taken so long to get here, we need to reduce our emissions so much more aggressively than a few years ago. So you can see this blue line here, like relatively gentle line. That's what we had to do before. Now, we're more like the red line. We need to go down really fast, okay? So there's lots of things that we need to actually do. We need to get our skates on. Now, I'm just going to give some perspective here, right? If you woke up tomorrow and thought, right, I have to do something about climate change, you're probably not going to start with thinking, oh, I'm going to change how I optimize images on my website. That's not the first thing you'd probably do. You'd probably have much more success using the web to change other industries rather than focus on making the web greener. So this graph from 2010 is a kind of global breakdown of CO2 emissions, all right? You can see loads of it comes from generating power, and you can see that a large part of it is transport. This is too small, but that shows road transport. Agriculture is another large one. Land use change, which is like deforestation, the kind of euphemism for that, that's about 10% as well. And I think if you look in here, there's aviation, which is too small, but that's like 1.5%. Like, where's IT? We're not on it at all. We're just like bundled into like other at the moment, all right? But it's, so you might think, well, okay, so we don't really do much. We're not part of the problem. But things are changing pretty quickly. So this report from the climate group Smart 2020 shows that in 2007, IT was responsible for about 2% of planetary CO2 emissions, so the same as aviation. And the thing is, it's growing faster. So do you remember how I showed that in the last slide? We saw how much power generation was a big part of this. Now, I don't sound like it, but I do live in Germany, and and Germany is the 4th largest economy on Earth, and Deutsche Telekom, a telecoms company, is the 3rd largest consumer of electricity in this country. So, you know, we do actually have some kind of impact. And also, if you look down here, we're expected to kind of double by 2020. So we may have started small, but we're growing very, very, very quickly. And as the web developers, we might not have direct control over deforestation, but we have rather more control over this stuff here, like data center use and infrastructure use. And that's what I'm going to be talking about. So I've been trying to come up with a mental model to help me take this stuff into account when I'm building websites or apps. And I'm going to share it with you today, mainly for feedback. I think there's a lot of overlap between what's good environmentally and what's just good practice for building digital products and services. And I think it's quite an interesting lens to look at through which to look at what we do. And I've broken it down into kind of 3 parts. So I've described it as like your servers, your packets, and your process, all right? Now, for your servers, there's loads of ideas we can borrow, recycle, if you will, from like software engineering, technical architecture, and from the DevOps movement. Now, for your packets, there's loads of ideas we can borrow from things like from web performance optimization. And for process, we borrow lots of ideas of like from lean UX and continuous delivery. So like with my research hat on, this is the kind of stuff like, how do you fit user research into your process when you're building a new product? Or how do you actually make product decisions that you then decide to like deliver with your development team? Stuff like that. I don't have enough time to talk about that. And but I do have a 45-minute talk specifically about that I gave in November that I'm more than happy to kind of point you to towards at the end of this talk. So let's start with this. Your servers. There are 2 ways that you might affect this. Choosing your provider and provisioning. I totally forgot to have some water. I'm going to try it very, very quickly. I've got notes to basically drink because otherwise I speak too fast. Okay. Your servers. Where did the power from your servers come from? Now, this is probably where we have the most direct effect, or the most influence directly. Now, previously, if you wanted to run your servers on renewable power, hence the kind of graph from before, you would probably run them in Iceland, where you have really, really clean, really stable geothermal power. Or you'd run with a number of small providers who either weren't very reliable or had very, very limited product offerings. But you're less likely to make that trade-off these days. So if you're in Europe, at least, Amazon and Google, they are running on renewable energy, or at least they claim to. And you can read all about this report in more detail here. So if you're using these two, and you're running servers in Europe, you've already made a decision that's reduced the carbon footprint of what you're doing considerably. Go you. The other thing you can do, the other thing that affects this, is actually how efficient you use the computing resources in your processes, all right? And for this, I'm just going to give you an idea of like how like the world uses the internet, right? So this graph is showing how most of us are asleep between the hours of 0 and like 9 o'clock. Then we go to work. Then we go home and watch Netflix, all right? So that gives you an idea of like that's our kind of usage curve, really. And for many of us, we're used to paying for compute by the month. So we don't really think about matching our reserve capacity to this. We just think about the headroom to meet the top end of traffic that we want, that we expect. The thing is, well, I think this is a missed opportunity. There is especially if we're thinking about the environmental impact of all this unused computing capacity that's just going to waste, all right? Feels a bit like leaving the lights on when you go home from the office, all right? And like this quote here from Adrian Cockcroft, who was basically the cloud guru at Netflix before he got poached by AWS, it kind of gives you an idea, right? So if you're building some kind of SaaS app, the chances are it's going to be used mostly for like 40 hours of the week, not between the hours of 1 o'clock and 9 o'clock, for example. So for the longest time, though, provisioning servers has been slow and hassle, so it's made sense just to leave the lights on because managing this has outweighed the cost of any savings you might actually make. But as we've started to move more towards services rather than servers, we've been trading like a higher per unit cost of compute for greater ease of management for these resources. So if we're looking at this through our planet-friendly lens, we might care about scaling it down, scaling our capacity down during periods of low use and burn less compute and therefore emit less CO2. And there are kind of clever ways you can do this, right? So like Heroku and Cloud Foundry and Google App Engine, all these things, they have like clever auto-scaling things. But you can also just do it on a timer, right? Like that's totally an option, and I'll touch on that a little bit later on. The other thing, though, is this is not the only model for compute, as Tom Dyson spoke about yesterday. So when you pay per response with functions as a service, you're not actually paying for any reserve capacity at all. You're only paying per response. So this changes how you think about like redundancy and failover. Like you're not paying to have redundant service for high availability anymore, right? And it also it changes how you think about scaling and versioning of APIs, all these things, right? I'm not going to talk about this too much because we had Tom blow our minds with this yesterday, but it's definitely worth thinking about. But there's the key thing that I do is like share this idea with you, right? Now, okay, it's fun playing with this stuff on a kind of nerdy level, but there's also an interesting financial side to this, all right? So let's say with AWS Lambda, for example, you are paying per response per 100 milliseconds multiplied by the amount of RAM you're using for that particular request, right? So if you can improve the code that services that response to go twice as fast, you've just halved your costs. And if you can serve the same request in half the memory, you've halved it again. And in many cases, less CPU and memory burned means less money spent, which also means less CO2 released. So into performance optimization, check you out, Captain Planet. You'll go far in this new world, all right? And you might think, well, I'm conflating performance with like in planetary, with the environment. And there's a reason I have to do this is because, well, Google and Amazon, all these large companies, they have very, very, very good incentives to make their data centers emit as the minimum possible CO2 because they have such high costs for this stuff, much greater proportion of their kind of business kind of operations than we might have. So, like, they don't really do it because they're warm, fuzzy companies. Amazon is the kind of apex predator of the internet, and Google is the poster child of surveillance capitalism, right? They may be kind of friendly people in one way, but they're not always your friends, okay? So they're doing it mainly because they want to save cash money, and they work at a scale where it actually makes sense for them to do that. So for them, planet-friendly is wallet-friendly, and if we're using them, then we kind of get planet-friendly for free when we use this kind of stuff. So in the Django toolbox, if you're going to be using something like platform as a service, stuff I've used before, Django is Django configurations. It just makes moving things around quite a bit easier. Also, I mentioned about kind of auto-scaling things like PaaS, platform as a service. Cloud Foundry, which is like an open source, in some cases cheaper version of Heroku. They have this thing called App Autoscaler, which lets you change things on a schedule, but also has clever stuff around autoscaling, which I don't really trust and understand, so I'm just going to probably stay with one of them until I look at it more. But Heroku also has the clever Voodoo autoscaling, but also has a thing called Light Switch, which you can probably guess what that does, right? I'd suggest looking these two up. In Python, as Tom mentioned before, there's Zapper and Chalice. I've been playing with Zapper before, and Tom played with Chalice, but since looking at Chalice, I quite like the idea of Chalice. The main difference between these two is that Zappa is not affiliated with Amazon. So the people who work there are, my guess is that they're more likely to care about not being locked into Amazon's wonderful golden cage than than Chalice, whose entire job is to sell more compute. The notes say take a drink, so I'm going to take a drink. Okay, the next thing is your packets. We've covered servers that you have control over, but once a request leaves your servers, you don't really get to control about how it routes its way to the web to reach a user. Like, that's kind of the point of the internet, really. So there's not much we might change there. But this is still, I find this really interesting anyway. So you don't have control over the servers, but you can still make some informed decisions about that. So this map here, electricitymap.org, basically shows the electricity mix of countries in Europe, right? So what you can see here is if the greener a country is, the more kind of planet-friendly the power is. So if requests are going through there, or if you're serving customers in there on like mobile or something, then it's going to be a bit greener. So France, full of nukes. That's why they're super green, right? Okay, England, full of gas, so less green. Ireland, really windy, kind of green. Germany, where I'm from, is the land of solar and coal, which is why it's this kind of mixed color here. So Norway, full of mountains, loads of geothermal, so therefore that's super green. Poland, full of coal, not so good. All right, Estonia also big into coal, that's why it's really black there as well. So this is actually done in real time, and I really recommend looking at this. Like the kind of energy nerd of me, this is like catnip for me, all right? And I'd really recommend looking at it. It's really, really cool. But as I said before, you don't have control over this infrastructure, so the decisions are more about how much data you send and how you end up sending it. Especially because as we start moving towards, say, using 4G for mobile, we end up with a massive kind of spike. 4G is much more energy intensive than 3G when it comes to sending data, and that kind of makes sense if you think about it. Like, you're sending much more information over in a shorter time. And this quote really kind of leapt out at me, right? So this is since the kind of move to 4G, we're seeing like wireless taking up a massive part of the actual footprint now. So this is a good reason to think about how you're sending data to people now. And like the thing is, we're seeing, not only are we seeing this shift, we're also seeing that people are using much more of it. All right. And what's to make things even worse, right, is that page sizes are getting bigger and bigger and bigger. There's an obesity crisis in web page size. So you can see a clear direction of travel here from 2011, which is like maybe about, what, a megabyte to more like 2 and a bit megabytes now, okay? Yeah. So this is kind of the opposite of what we want from a CO2 emissions perspective, all right? And you can see the images, like, you can see the culprits, right? Mostly images, mostly JavaScript. And like one technique the web performance community has used to help fight bloat has been the use of performance budgets in designs. So while the goal here is to just provide a better user experience and a faster loading site, it turns out to be pretty planet-friendly to send less bits, as we've just seen in the last few slides. So because we're reducing the amount of energy, and therefore CO2 being chucked into the atmosphere. Now, this site, you basically put a number in, you say how you're going to get to it, and it will give you a number, and then it says, like, well, you've got this much to spend on images, this much on JavaScript, and so on. It's really easy to use. And once you have that, you can think of this like writing your test, and then you've got CI for this. So this is a tool called Speed Curve, and what they do is they'll basically look at your website in production and see how quickly it loads, and how it paints, and how pages render, and basically whether it stays within this performance budget. So I know that Uswitch, a large company in the UK that does switching for energy, they use this to benchmark their own site and used like these two tools to reduce their web page size to about 600K, which is like less than a third of like the average size these days. If you want an open source solution, SiteSpeed comes as a Docker container, and it does a lot of the same ideas. So like you can use this without being wrapped into a proprietary company if you want. The other thing you might want to do is basically how much of what you send to the client is actually necessary, all right? So if you went to school and you ever were served school dinners, you might remember that you didn't get much control over what was sent to you. You just got given a portion of food, and regardless of what you wanted inside it. It's not that different when you think about how people use websites, right? When a user goes to a website, they get sent loads of things they don't need, and like they might just want a drop down, but they get hundreds of K of JavaScript, a whole bootstrap's worth of CSS, regardless of whether they're using any of this. And I think as developers, we often make kind of, one thing we do against this is make kind of decisions to make a kind of lossy trade-off. We would deliberately might reduce the image size or quality, and we might omit unused code to deliver a faster loading, better user experience. And that's kind of, that idea I think is quite useful for us. The other thing is, once you've kind of reduced as much as you can, there's kind of more lossless changes. And I kind of fit into here, things like compression and caching. So when I gzip or minify files, I'm not changing functionality, I'm just making it much, much smaller. All right? So I know having less data to deliver. And in the Django toolbox, that shows some of this here. So I've split it into kind of like the 3 main kind of requests that I think we tend to use. So for lossless stuff, like compression and caching is stuff that you tend to use anyway, all right? Now for static things, white noise is a nice tool which makes it easy to deploy static files on Heroku and things like that, but it also makes it integrating with a CDN quite easily. And Nginx does some of this anyway, as we know. Well, I say we as the entire room through not individual people, I suppose. Likewise with media, you got the same thing happening here. When it comes to the kind of more lossy optimization, there's things like Webpack 2, which is, yes, it's some other kind of hipster JavaScript stuff, right? But this is really, really clever. It does a thing called tree shaking and basically looks at the paths that your code's going to use and only serves a small custom bit of JavaScript for the kind of paths your code might actually take. All right. Also, with Nginx, there's this open source module called mod page speed, and essentially that will automatically like minify and do very, very clever things with JavaScript. So you don't need to be some front end guru, because I don't know about you, I still don't really understand Webpack, but I know it can be a bit scary. So if something else does that for me, great. Likewise on the image size, on the image front, there's tools like ImageOptim, which you can do like use locally to just like optimize and strip out stuff in your images that you don't actually need that might also be disclosive. And if you're on Linux, there's a thing called Trimage, which is very, very similar. And now that we've seen how you can do those functions as a service, you could quite easily imagine that being like a part of your pipeline when people upload images to get them automatically reduced. Likewise, with easy thumbnails, okay, show of hands who's heard of easy thumbnails or used it before? All right, now keep your hands up if you're also using easy thumbnails.optimize, which basically strips out all this stuff. One person, you sir, you are the new Captain Planet. But that's the thing, right? You just get rid of a little bit of data and you make it faster, all right? Likewise, with Nginx, that does the same thing for you as well. They also, so there's this module for Nginx will basically take your images, minify them, well, optimize them, serve them from a new location, and do all this stuff kind of magically, and it makes your website work a bit faster. So there are ways that we can affect what we send, and that has an environmental impact on that. And in many cases, you end up with a better user experience because pages end up loading faster, and we also end up paying less in terms of CO2, and also paying less financially in terms of bandwidth if you're using some kind of CDN or anything like that. So this is like this. I need to kind of make it clear, right? I hope this has given you a better understanding of what you can do as developers, and also how what you do fits into the kind of global picture. And it should give you an idea that like some of what you're doing already has an environmental impact, right? And you might already be doing the right stuff, okay? Now remember those graphs we had at the beginning of the talk? Like, if we want to stand a chance of staying within that budget, we're going to need to be able to see what we do from an environmental perspective. But fortunately, and if there's one takeaway I want you to take from this talk, it's this: making a site work better for the planet is basically the same thing as making it work better for users. So the chances are, many of you in this room already have spent years becoming black belts in planet-friendly web ninjutsu. Like, hear that, Neo? You already know Kung Fu, all right? So in your day-to-day jobs, hopefully this talk has given you some ideas for a number of good places you can start putting this into practice. And so I'll end with channeling all of the 90s childhood cartoon nostalgia I can muster for this. The power is yours. Thank you, everyone. Okay, I won't be answering questions here, I'm afraid, but I'm really keen to talk about this on Slack because, well, I've used more time than I have. Finally, this is a life-changing link. right? Go look at this essay. It's really, 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 really cool. And if you want to go beyond web optimization, this is the one to go for. This will change your life. All right, that's me. I think, yeah, that was actually faster than I thought. Oh God, I'm so sorry, text-to-speech ladies. I've given you such a hard job, haven't I? All right. Okay, I'll be around for all week. If you liked this talk, I'm going to be doing it again at PyCon Italia in a few days' time. So you can, I don't know, say, the power is yours as well at the end. Okay, that's me, everyone. Thank you.
Thank you, Chris.
Oh, it's online at Slideshare, by the way. So if you look up chris.do.adams on slideshare.com, you'll see the entire thing, because there was loads of links and I barreled through loads of information way too fast. Okay, thanks, everyone.